people that are going to be attending the 2022 AOGS meeting in Honolulu can expect, in addition to a really outstanding program, lots of other cultural things that we have planned. For instance, what we had planned and what we did in 2018 was a tour of the Pacific Tsunami Warning Center, tour of the Hawaii Institute of Marine Biology facility, part of the school that I work with, the School of Ocean and Earth Science and Technology. Have a group of coastal geologists who led a field trip around the south coast of Oahu. There were a couple different walking tours around Waikiki, one that had a sail extension, meaning going out on a sailboat. The things that unfortunately we were not able to do last time were field trips to the Big Island to see Hawaii Volcanoes National Park. Of course, 2018 was when we had the last big eruption of Kilauea. So those field trips unfortunately had to be canceled. But next year in 2022, there should be lots of really interesting parts of the Big Island to see where the 2018 eruption happened. Other possibilities also will be to visit southeast Oahu to look at the geology of that area, including the Hanauma Bay area. And of course, lots of free beach time after the sessions are over. Well, as you know, in the past year, tourism was basically shut down in Hawaii. We had hardly any visitors from off the island. Of course, the economic impact to our state was not very good. On the other hand, the natural environment was really happy to not have so many people crowding the beaches and swimming in the offshore areas. So the biggest impact of this 1 year of no tourism has been the shall we say, renewal of marine life. Areas that are now reopened, like the popular area of Hanauma Bay and areas of the North Shore also, people are reporting that there are so many more fish than there used to be. In addition, Hanauma Bay has now instituted a reservation system. This is going to control the number of visitors, and marine life is expected to continue to thrive. Many of the parks and hiking trails, because they were shut down over the last year, the city and county took the advantage of that to upgrade the trails, make the parks a little bit more beautiful than they already were. So there were some nice advantages to not having so many people around last year. Honolulu is really a great city for having the AOGS meeting, as we found in 2018. We have a great convention center. That convention center is close to the hotels, just a short walk from the beach, lots of good restaurants around. Personally, the things that I like most about living in Honolulu is access to the ocean. In the evenings, on the weekends, my friends and I have been paddling our one-man canoes, usually at least 3 times a week, sometimes more. I've also recently been doing some scuba diving and hope to be doing some more of that. Of course, weather is a big attraction. June is probably one of the best months of the year. Not very much rain, not too hot. So we think that the venue, again, should be perfect for our convention attendees.
This time, it'll be different. I'll wake up for that sunrise. I'll look with my eyes, not my phone. I'll slow down to see every little thing. I'll make tomorrow a brighter place. I'll stop to smell the flowers. I won't just do it for the gram. I'll say yes to everything. This time, it will be different.
Good morning, ladies and gentlemen, and welcome to AOGS Live in Singapore. My name is El Kwang, and I'm your MC. Today, we are beaming live from Marina Bay Sands Hybrid Broadcast Studio. Now, to our in-person participants, thank you so much for coming here to support us. To our virtual participants, if this is your first session, God, we've got a wonderful treat for you just a little bit after our little speech here. But for those who are joining us back again, thank you so much for your support. Now, today we are here to talk about is our desire to explore the unknown world driven by science or other interests? That's the questions that we'll be answering in today's Exploration and Science panel. Before I hand over the screen to what I call the man of the moon, you know him really well, Take, I beg your pardon, Take, it's the morning, it's morning in Singapore, all right? It's Sato-san, and just a little bit of an interesting fact because we shared the passion for running, and apparently since the beginning of this year, Sato-san has already accumulated 650 kilometers running. So no lockdown can prevent him from his passion, his patience, and his tenacity, and whatever he does for AOGS. So without further ado, please welcome Sato-san for his welcome address. Thank you.
Thank you, El. Okay, good morning, everybody. Either in person or either participating remotely, virtual. And this is the first ever we have AOGS live in Singapore from hybrid studio at the Marina Bay Sands. So actually yesterday we had a very, very interesting session about climate change. And today we have this science and exploration, and another one, geoscience, education, future opportunity sessions. So I really happy with many very talented panelists I invited for today's session. And of course, it wasn't possible only by myself, but we have a wonderful team. Two co-organizers, Benoit Tayson and Robin Robertson, and of course, AOGS Secretariat and the staff members at the MBS, and all helped us to realize this wonderful event. And we now have a message from our society's president, Professor Chunchi Wu. Unfortunately, Professor Wu cannot make it today, but he sent us video message, very brief one, but we now are going to hear his welcome message, and then I hand my microphone back to El. Okay, so now we see Professor Wu's message.
Hello, everybody. On behalf of AOGS, it is my great pleasure to welcome all of you to attend our first ever AOGS Live in Singapore hybrid event. First of all, let me thank Takehiko, Manuel, and Robin for organizing this special AOGS event. The focus of this event is to discuss current issues such as climate change, science exploration, and geoscience education. This event is an essential activity for AOGS to engage with the community for facilitating debate, information sharing, and providing networking opportunities. Again, appreciate your support of AOGS and wish you have a fruitful time in this special program, AOGS Live in Singapore. Thank you.
Thank you, Professor Wu and Sato-san, for your brilliant words. Now, earlier I mentioned a little bit about don't worry if you missed our session yesterday, because I have sort of brought on one of my friends yesterday. His name is Crystal Alexander, General Manager of Song Division Asia, who is a very talented musician. And what he did was he joined us at our session yesterday, listened to all the keywords, and overnight his team produced this amazing video on climate change, because all of us want to join this movement in communicating the importance of climate change. So without further ado, let's play the video for you.
These are the words that we need to hear. Listen to the message, it's loud and clear. Professor Thorne got the facts around our human influence, uncharted territory with multiple references. Dr. Raghavan gave us the science of climate change on our water cycles. Vesico helped with dynamic evidence to help with the scientific confidence. The ocean is hurting from our human pressure. Modern call to change our ways forever. Yeah. Climate change will not beat us down. It affects us all. We must answer the call. And it starts with us, and we must start now. Well, Francisco helped us understand the information and the problems caused by urbanization. IPCC poured over the literature to give us the truth, the bigger picture. It's a hard time. Budgets and the AR6. Professor Canadell is in the mix. Professor Lee has shown us the way to improve day by day. We know the sources, so we know the solution. It's time for action. Yeah. Climate change will not beat us down. It affects us all. We must answer the call. And it starts with us, and we must start now. Future students are the key to fixing our mistakes. The time is now, no higher stakes. It affects us all, we must answer the call. Climate change will not beat us down. It affects us all, we must answer the call. And it starts with us, and we must start now. These are the words the words we need to hear.
Listen to the messages loud and clear.
Time to listen.
Our children's world is in our hands. Today is the day to take our stand.
Wow, isn't that a beautiful song? I hope you enjoyed it as much as we do here. Feel really, really inspired by that. Okay, now this is the time where we're entering into our panel discussion. So this is how it works. Each of our experts will present for about 8 minutes. So for our virtual participants, this is the time to start chatting because I can see Stephen, Ramesh, Robin are saying hi to everyone online. So good on you. Keep saying hello. Next to the chat box is our Q&A box. We would love you to submit as many questions as possible and challenge our panelists. So for our in-person participants, if you have questions, please just put up your hands and one of our team members will bring the mic to you. Just a gentle reminder to keep your mask on at all times. So now our panel moderator is Mr. Chris Lake, and he is the Deputy Executive Director of the Office for Space Technology and Industry. Just a little bit of a fun fact. Before joining the venture into space, Chris was actually working on self-drive cars. And when it comes to Singapore, he loves where he lives, Katong. So for those of you who have never been to Singapore before, Katong is one of the residential hub, but really amazing where you find a lot of houses and great food like laksa, a lot of cafe. It is a real hub if you want to understand what Singapore culture is all about. So without further ado, please join me in welcoming Chris Lake and his panels of experts on stage and on screen.
All right, good morning, everyone. Well, good evening, I think, to some of you who are joining us virtually as well. I think it's a pleasure to have all of you joining us. So welcome to this panel discussion on exploration and science, where we will be discussing how we can explore and uncover true science, as well as perhaps a little bit of the law as well, what remains of some of humanity's greatest mysteries. And I'm talking about outer space, the deep sea, of course, and even the Earth itself. So it's a real privilege for us to hear from 6 very distinguished speakers this morning or evening on these issues. And perhaps without further ado, because we do have only 1 hour and I think quite a number of speakers to go through, let me just very quickly introduce all of the speakers in the order that they will be speaking. So first, we have Professor Iko Funaki, who's the Deputy Director of International Strategy and Coordination at the Institute of Space and Aeronautical Science at the Japan Aerospace Exploration Agency, or JAXA. The second speaker that we have is Professor Hideaki Miyamoto, professor at the University of Tokyo, who specializes in planetary science. We also have Professor Liu Ziyu, Associate Dean, College of Ocean and Earth Sciences at Xiamen University. And they are joining us virtually through, I presume, Zoom. Here in the audience with me, or in the studio with me, I have Professor Sang Ho Yun, who's Director of the Remote Sensing Lab at the Earth Observatory of Singapore and also Associate Professor at the Nanyang Technological University. And we have Dr. Santo Salinas Cortillo, Senior Research Scientist, Center for Remote Imaging, Sensing and Processing at the National University of Singapore. So gentlemen, thank you all for joining us this morning. I think to all the speakers, as I mentioned, in the interest of time, as we only have an hour and quite a number of speakers, maybe if I can suggest that we can just have the speakers run through your presentations, and then we will then move on to the Q&A segment. So to the audience, I think as Elle mentioned earlier, you will have the opportunity to pose some questions to the speakers. So please do submit them. But I think for those in the audience here, I would ask that you hold your questions till after the speakers have gone through their presentations, and then we'll have the Q&A. So maybe without further ado, can I invite our first speaker, Professor Iko Funaki, to share with us his presentation on sustainable lunar exploration. Iko-san, please.
Thank you for your introduction. So, good morning, everybody. My name is Iko Funaki. So, I'm going to talk about two aspects of sustainable lunar exploration. One is science-driven evolution, and another one is participation from industry. So, I'm currently the director of Space Exploration Innovation Hub Center, JAXA. And sustainable lunar exploration is the main theme of our center. So please click and go to the next slide. Thank you. So this page shows the summary of my short presentation. Currently, lunar exploration is actively going on, as you know, but there is a large gap between existing exploration plans and the future best utilization of the lunar. For sustainable growth of lunar utilization, I believe science plays critical roles to bridge the gap between them by guiding participants and collaboration of a variety of organizations and nations. Click, please. Another topic is for such science missions, in addition to participation of scientists, participation of engineers, in particular business persons from industry is important. And JAXA Space Exploration Innovation Hub Center, my center, provides unique opportunity to foster non-space industry to participate in the lunar exploration. And that outline of our activity is briefly introduced to clear discussion. Please click and move on to the next slide. So this slide shows lunar exploration and contribution of science missions. Lunar exploration by space-within countries are very active, as you know. Artemis, Chang'e, Chandrayaan, India. Example, Japan has Smart Lander 3, Polar Rover mission IPEX, Gateway with United States and other participants, or lunar cruise and so on. So there are a lot of activities happening, but in spite of a large gap between near future plans, you can see the picture on the right-hand side from the bottom, and the far future vast matured utilization you can see on the upper right-hand side. So click please. To bridge the gap between these two, I think science plays a very critical role. Please click. And click again. So you can see technology demo route, and in the right-hand side, various science missions can bridge the gap between the two. Click please. So such activities can be done because science mission can reveal the lunar surface and environment that are useful for future lunar explorations. And science mission will be in a variety of scale. So step-by-step technology advancement is possible. And science mission can motivate involvement of scientists so that worldwide persons get together and form large communities for future space utilization. Please. For the above purpose, a variety of missions are expected, and mission scenarios being considered in Japanese communities are displayed in the next slide. Briefly. So this is the reference slide showing lunar science currently discussed in Japan. One is lunar magnetic network to survey the interior structure of the moon. to clarify the size and boundaries between trust, mantle, and core, and so on. And the second one is sample return from the moon surface. It's exciting to review the age of the early Earth informing impact. And third one is astronomical observation from the moon. It's quite far future plan, but I think it's important for a future mission, which is impossible on Earth. Please click again. And another topic I want to talk is enhancing partnership for sustainable lunar exploration utilization. For future evolution toward lunar utilization, as I said, participation from industry and business persons to related R&D is quite important. This is because final goal is not just exploration, but lunar utilization that provides a lot of business chances, not only science chance. And it is not possible without this participation from industry. So to guide industry to participate in R&Ds on exploration, JAXA's Innovation Hub Center provides open innovation schemes as shown in the right-hand side figures. Please click and click again. Click again. Thank you. So the Hub Center sets, you can see 5 research fields for lunar exploration. That are very analogous to the existing field on Earth. You can see on the bottom-hand side. So, and we try to obtain 2 objectives simultaneously. One is new technology that can be used for the lunar exploration and new technology that can be used for business on Earth. Also, JAXA provides funding for collaborative R&Ds, and about 100 research activities are currently finished, and about 30 are currently going on. Please go to the next slide and click 5 times. Thank you very much. And these are the collaborate R&D examples. Please click again. Click, please. Yeah. Japanese industry and JAXA Space Exploration Innovation Hub Center are doing so a lot of things on exploration, left-hand side, production, and construction for the future lunar base and habitation activities. So a variety of activities for future lunar utilization is also going on at JAXA. And we are going to also support important science missions as well. So that's the end of my presentation. And please go to the next presentator. Thank you.
All right, thank you very much, Professor Funaki. I want to also let the audience know that we do have Professor Michelle Hanlon with us as well. I think she wasn't in earlier, but we managed to get her online. So she will be speaking a little bit later, but I thought I'll just quickly introduce her as well. Professor Hanlon is the co-director of the Center for Air and Space Law at the University of Mississippi and co-founder and president of For All Moonkind. So she will come on a little bit later. But next up, we have Professor Hideaki Miyamoto to share with us his presentation, which focuses on asteroid exploration. Professor Miyamoto, you have the floor.
Yeah, great, thank you. Hello, my name is Haruhi Miyamoto. Haruhi is just a nickname, actually. I'm from the University of Tokyo. First of all, I'm very much happy to be here as a panel. Thank you for inviting me. It's a very exciting panel, so I'm kind of enjoying already. Anyways, my expertise is about the space exploration, and it's very fortunately I'm involved in many space exploration and share this very exciting time of discovering many new new things in the solar systems. It's a great moment for doing that with lots of many scientists and engineers. So let me talk about a little bit of the current advance of this asteroid exploration. Actually, there are too many great achievement, great things that I have to tell, but the time is limited. So I can just give you some quick overview of what's going on in the asteroid science, and as well as some aspects of resource exploration. Next slide, please. So the next, please. Thanks. The asteroid was first discovered in 1801. It was series by the Giuseppe Piazzi, and immediately after that, 3 more Pallas, Juno, Vesta were found. The discovery continues actually. In total, 300 asteroids are discovered by 1890, 1,000 by 1923. 10,000 by 1997, 20,000 by 2000, and now it is more than 1,130,000 in the solar system, as shown on the right of this slide. The scientists believe that perhaps more than 3 million asteroids exist, at least 3 million in the solar system. But asteroids are too small for observing from Earth, so their shapes has long been unknown until spacecraft observed them at a closer distance. Next, please. The Galileo spacecraft fly by an S-type asteroid, the Gaspara, in 1991, and IDA in 1993, as shown here. And at that time, we could figure out the shape of asteroid as something like this, and it's very similar to those expected by scientific movies, actually. The Near Shoemaker spacecraft was first mission to asteroid, specialized to the asteroid exploration, and it explored Matilda in 1997 and the Eros in 1998, touched down on that, so we got the close-up image as shown here. It's a very exciting place. So this exploration kind of initiated by these space missions and followed by other missions. Next, please. In 2005, the Hayabusa spacecraft performed close observation of asteroid Tokawa and collected samples. In the past, the origin of asteroids is, of course, there are lots of discussions, but it was not that too obvious. But the observations of the Hayabusa spacecraft and also the return sample analysis proved that the most meteorites are actually fragments of the asteroids. So meteorites, asteroids are very important connection. Next, please. Comparing the meteorites and asteroid observations become very important. And advances in meteorite science, as well as sample analysis, are now directly linked to the observational studies of asteroids. So we have good systematic observation systems as well. So a combination of them roughly gives some ideas of the compositional nature of asteroids in the solar system. So in other words, we kind of know what kind of materials are existing on which type of the bodies. So I'm talk about a little bit about the resource exploration based on that knowledge. Next, please. So this is very, very much simplified delta V map near Earth. As you know, the motion of spacecraft is governed by its orbit, and it is a function of relative velocity of celestial body. So the delta V is the value of the total velocity change, which is a useful index to estimate the fuel consumption from one body to another body. So as you know, the Earth is the biggest rocky body in the solar system. So just going to the low Earth orbit is very pricey. We need 10 kilometers per sec delta V for that. It's a big value. Comparing, once we are in the orbit, just LEO, the low Earth orbit, from there to the moon, the lunar orbit, it is only about 3 kilometers per second. So much smaller than from the Earth's surface to low Earth orbit. The Mars is far from the Earth, but still it is only about 4.3 kilometers per second. But comparing them, asteroids is much smaller. I mean, depending on the types of the asteroids or orbit of them, but it can be 0.1 or a little bit larger than that, significantly smaller than going to the other large bodies. So this means that getting something from asteroids can be done with limited amount of the total fuel. Next, please. So science exploration, it's great time. Many great science discoveries by science mission. This mission revealed that there are lots of useful resources exist in many bodies, such as comets or asteroids, moon as well, of course Mars. Next, please. But maybe in the future, next, please. Thanks. Volatiles may be the key. Volatiles on such bodies may be mined and consumed on the moon, Mars as propellant. But on the or maybe the volatiles are mined from asteroid or the moon and transferred to some storage station in the orbit, which may be serving as a kind of gas station for robotic or manned mission in the future. Next, please. And we have very good discoveries, recent missions. We kind of know the shapes or appearance of rubble pile small asteroids. So it probably gives you some ideas of how we can mine something from that kind of bodies. And in fact, Hayabusa 2 mission successfully obtained and returned samples back onto Earth. So we can do this. Next, please. And we have a series of future very exciting missions, and they are all funded. So I'm convinced further significant advances will be brought from all of these missions. Next, please. Next is just a summary of my talk. And the photo on the right is actually a book I'm organizing with some of my friends about the space manufacturing and the resources. So if you're interested, maybe you can take a look. Thanks.
All right, thank you very much, Professor Miyamoto. That was an excellent presentation. Next up, can I invite Professor Liu Zhiyu to share with us his presentation on deep sea exploration? Professor Liu? Professor Liu, are you there?
Sorry, Chris. Professor, we're having connectivity challenges with Professor Liu. I was just wondering whether we can proceed first with the next panelist that you have?
Yeah, sure.
Thanks.
So the next panelist is Professor Michelle Hanlon. Michelle, are you connected with us as well?
Yes,
Would you? Yes, please start your presentation.
Perfect, wonderful. Well, thank you so much. I don't have slides because I'm the boring one today. I'm the space lawyer. First, I want to thank you so much for having me. I am so delighted to be here presenting with these amazing professors and all this research. This is one area where, as so often happens with technology, the law is so far behind. And I really loved Professor Miyamoto's presentation because it's really what I'm focused on, and that is being able to support space resource utilization, whether in situ or bringing it back to Earth. So I just wanted to talk a little bit about what laws we have. You know, the law, the outer space is not sort of a wild, wild west lawless frontier. We do have the Outer Space Treaty, which has been in force for 54 years. And with the fundamental concept of space law is freedom of exploration and use. So that means anybody, any nation, people say it all the time at the UN, space is for everyone. And that is the law, that is the truth. It's not just enshrined in a treaty, but it's recognized as customary international law. So whether or not you've signed the Outer Space Treaty, it's understood on Earth that all of space is free for the exploration and use by all. So what does that mean if everyone's looking at the same spot on the moon for volatiles? Well, the other thing that the Outer Space Treaty says in Article 2, it says that a sovereign may not claim territory in outer space. A state may not by sovereignty or any other means. And so nobody can actually go up to space and say, I claim this asteroid and I will mine it. And there has been in the international legal community, there's some discussion about whether that only binds states, that's only countries. So Singapore can't claim territory, but maybe a private entity from Singapore or a private individual can. That's still being worked out with the international community, but I think it would be disingenuous to suggest that that could happen. So how do we make sure that we can support programs like what Professor Miyamoto was talking about, while also preserving peace in space? And so the only things that sort of narrow this broad scope of freedom and of exploration and use is a military provision. Space must be used for peaceful purposes, and Article 9, which says that all activities must be implemented with due regard for the activities of all other states and all other entities in space. And so what does due regard mean? Well, to you and to me, it means let's be considerate of each other. But, lawyers have to complicate things all the time. To lawyers, due regard is a balancing test. It says, well, we're going to look at all of the circumstances, and we're going to look at what did party A do and what did party B do and what happened and who did what and who was hurt and so forth and so on. And so every time you have a conflict in space under current law, I always like to say you're paying a lot of lawyers to bicker for a long time. And that is just a tragedy, because we want that money not to be spent on lawyers like me, but to be spent on researchers like Professor Miyamoto. So what can we do? Well, the United States has taken some steps. In 2015, President Obama signed the Asteroid Act, which said the United States interprets Article 2 to say, okay, we cannot claim territory in space, but if we extract resources from space, then we can use them and sell them. And that was quickly followed by Luxembourg, and UAE now also has a similar law. So there seems to be a consensus growing that, yes, all these volatiles that are available, we can actually extract them and use them, and we won't be in violation of the Outer Space Treaty, and we will still be able to enjoy this freedom of use. But what that doesn't answer is this conflict. What happens if two parties, two states, two entities want to look at the same area on the moon to mine those volatiles? Well, the US promulgated the Artemis Accords, which has 12 signatories right now. And they said, we'd like to set up a concept of safety zones. We think due regard means that we will negotiate sort of barrier, buffer zones. We won't call it territory. We'll just call it sort of, notification zones. So this is where we're going to be. Please don't come here. Russia and China, they have not objected. There's a lot of talk in the media that Russia and China are angry. They've rebutted. They have said the Artemis Accords are wrong or bad. That's not true. Russia and China have taken the stance that the Artemis Accords were incorrectly introduced, that any space law, contract, agreement should be convened, should come out of the committee, the United Nations Committee on the Peaceful Uses of Outer Space. They have not said the Artemis Accords are wrong. They have not said safety zones are a bad idea. What they have said is they are going to build their own base on the moon, and they are inviting other countries to come with them. So what do we have? We have now potentially two bases on the moon, one under Artemis, one under the Chinese and Russian partnership. And how are they going to work together? So what I like to tell everybody is one of the most important things about space, other than the freedom of use, freedom of exploration, is this concept of the overview effect. Captain Kirk Bill Shatner went to space today, and he came back in tears and said for the first time, he really realized that we're all in this together, what it's really like. I believe we need to have two bases on the moon, two separate kinds of entities and parties. And what they're going to do is they're going to need each other. They're going to look at Earth every day and realize that we're all in this together, and they're going to need each other. And they are the ones who are going to figure out the best ways to implement things like safety zones and mining rights and so forth. And we will actually achieve peace through space. But in terms of just for the work that you all are doing for this concept of exploration and science, the law, again, is far behind, completely supportive of all of the scientific collaborations, of all of the scientific uses. The Outer Space Treaty is very clear that one of the primary focuses of space exploration should be the science. And in fact, we have a provision called the Planetary Protection Principle, where we cannot contaminate another planet in case there's life on that planet, in case there are clues as to the origin of life on that planet. So we're working very hard, the space lawyers back here in the corner, to make sure that we have the proper regulations and guidelines to assure that we all are able to explore space, and we are all able to explore space sustainably and successfully and responsibly. And I really look forward to your comments in the discussion, and I will save my time for any future questions. Thank you again, and thank you again for having me.
Thank you very much, Professor Hanlon. Most interesting, and I think we have a lot to chew on. Maybe if I can ask the technical. Okay, so Professor Liu is not with us yet. So perhaps next, if I can ask Professor Sang-Ho Yun to give us his presentation. I think Professor Yun is going to speak about synthetic aperture radar for planetary exploration. Sang-Ho, please.
Thank you, Chris. Welcome. And thank you for inviting me. For the past 13 years or so, I've worked for NASA's Jet Propulsion Laboratory, and I started new positions in Singapore just 2 months ago. I am very excited about this opportunity to formulate and lead this new remote sensing lab at the Earth Observatory of Singapore. And this presentation, I'd like to show you some use of remote sensing for planetary exploration, including our own planet. Exploration is human nature, and we already visited or passed by all the planets in this solar system. And this is our solar system in a logarithmic distance scale. And in the following few slides, we'll take a closer look at Venus, the gray one next to the Earth, and Titan, the largest moon of Saturn. Venus was visited by NASA's Mariner 10 mission in 1974, and then again by NASA's Magellan mission in 1989. On the left is an optical image from Mariner 10, and then on the right is synthetic aperture radar, or SAR, image from Magellan mission. And two things to note about the optical image. The entire planet is very cloudy, and also, therefore, we can only see the clouds on the sunny side. Whereas on a SAR image reveals the details on the Venusian surface despite the thick clouds, because radar can penetrate clouds and can image day and night of the planet. Now let's look at Titan. It's the largest moon of Saturn. It's about 50% larger than our own moon. And on the left is an optical image captured by Voyager 2 in 1981. And later on, it was visited much closer by Cassini-Huygens mission. And on the right, you're seeing the true color image of Titan, hazy atmosphere surface. Cassini carried a SAR sensor and imaged the surface of Titan, and they discovered that there are gigantic lakes on the surface of Titan made of methane. And on the right is you're seeing the false color image in blue, imaged by SAR sensor of Cassini mission. And these lakes are so huge, the combined area of the lakes here is almost 800 times the area of Singapore. And our own planet also have clouds, and sometimes with fierce wind and rains. And this is the true color image of Category 5 Hurricane Dorian that hit the Bahamas in 2019. And let's take a closer look at this area. This is the blow up. The white image here is not a white box, not white solid color, but it's still a true color image of MODIS sensor overlaid with the Bahamas coastline. And as you can see, you don't perceive anything. Then we process SAR data acquired from European satellite, acquired on the same day as this image. And voila, you see, here it is. SAR can penetrate the thickest and the most torrential rains on this planet. The optical image in the background is on a sunny day, optical image, and the sky blue pixels on land indicates areas as mapped by SAR that are likely flooded by this hurricane. Well, SAR uses single frequency microwave signals, and this brings a very important potential, which is interferometry. Using interferometry, we can do a whole lot more than detecting the water bodies on the planet. In here, interferometry, with interferometry, we can create geodetically accurate topography, or we can measure millimeter scale ground motion. And as you can see here, we can create what is called damage proxy maps. In the middle panel, the red pixels indicate the areas that are likely damaged or disturbed by this hurricane. And earlier this year, I worked with the visual team of Science magazine, and our map was featured on the cover page of Science in February issue. And hurricane damage is not the only kind of damage we can detect. Our damage proxy maps can detect building damage due to earthquakes, land damage due to liquefaction, and landslides, tsunamis, volcanic ashfall, tornado, and wildfires, or in this case, chemical explosion damage. We derived this map using Copernicus Sentinel-1 SAR data acquired only after 30 minutes after the huge explosion of ammonium nitrate in Beirut, Lebanon last year. Our map rapidly provided comprehensive coverage and has been used by many NGOs, response agencies, and private companies. And it also drew a lot of media attention, including BBC News, New York Times, and National Geographic. My team back at NASA JPL and currently at the Earth Observatory Singapore supported more than 100 major disaster events around the world. We're very excited to formulate this new remote sensing lab at the Earth Observatory Singapore Nanyang Technological University. And we envision continuing to strengthen our collaborative and trusting partnership for better and effective humanitarian assistance and hazard analysis. Our lab is only 2 months old, and we're starting small and efficient with 1 PhD student, 1 mission controller, and 1 DevOps lead, and myself. We're all passionate, eager to learn, and eager to innovate. Thank you.
Thanks very much, Sang-Yun. Sang-Ho. So last but not least, I think we have Dr. Santo. Dr. Santo, perhaps over to you for your presentation.
Thank you, Chris. Good morning to everyone. Welcome to this live AOGS session. Right. I'm from the Center for Remote Sensing of the National University of Singapore. We have been a few years doing remote sensing in the Southeast Asia region, especially in Singapore. And our center started in 1992 with a clear mission to develop an advanced capability in satellite remote sensing to meet operational, scientific, and some business requirements for Singapore and the region. And that was our goal, and we continue to strive to achieve such a goal. In our center, we host about 4 large satellite receivers to cater from the commercial satellites up to the environmental satellites. We continue to receive most of the commercial and environmental satellites. For example, you have Terra Modis, Aqua Modis. Some of them do not broadcast anymore. But we have also the Singapore Earth observation satellites that they are already in orbit, and some of them are coming in the years to come, 2022 to 2023, and all of them in near equatorial low Earth orbit. Some of these satellites will be interesting for Earth observation in the region. In our institute, we mostly study the classical areas of remote sensing, that is land, water, and atmosphere. So I'm going to give you a brief view of what we have been doing in the last few years. For example, in land remote sensing, we use the power of satellite to identify, for example, forest fires. That is an event that occurs almost every year with certain frequency. And you can imagine the power of satellite. You cannot study this thing without satellites. And for example, here we have a very coarse resolution from XSAT, for example. And you can identify the fires by using, for example, Worldview, which is a much more higher resolution satellite. You can also use the power of satellites to study land change, for example. We have a map, for example, of the year 2000, and 2 regional maps from 2000 and 2010, so you can identify the land, how much land has changed over those periods of years. And these are very important because you can actually use it for climate impacts, for example. In water remote sensing, for example, we do inland water air quality from satellite images. In this example, you have, for example, from a spot, and we quantify them by doing a validation, for example, for in-ground or in-situ measurements, in this case from reservoirs across Singapore, for example. We can also do remote sensing over the oceans to detect water depth, which is very important for marine ecology, for example. And we can identify also other parameters that defines water quality. This is an area of my research, my personal research in the last few years, is atmospheric remote sensing. And for example, many of you might know the great Southeast Asian haze that happened in 1997. That's one of the first haze events recorded in Southeast Asia. We now use the power of satellites, for example, like MODIS or the latest satellite Himawari 8, to study these, identify these hotspots and the transboundary haze that comes from the land masses of Sumatra and Borneo, for example. We can use that and complement with the in situ monitoring, like for LiDARs and some photometers, to identify the smoke or the haze that we call it here, and create maps, for example, regional maps of aerosol concentration of PM 2.5. And we complement that with numerical modeling, for example, so that we can understand how these particles are distributed. Another area that some of my colleagues are doing is polarimetric SAR research, and essentially try to identify man-made objects over residential estates, over some deposits, industrial or even airports. They use different types of polarimetry and to do this kind of studies. Another very interesting areas, for example, we recently been engaging is machine learning and deep learning. We can identify, for example, use it for aircraft detection. And this is an example of some of the work being done. And we also do for ship detection, which is very important because Singapore is a shipping port. And this is a very interesting step to automatize this kind of detection. And so this is some of the areas that we are exploring at CRISP, and we expect to have much more details in future meetings that we might have here in AOGS. Thank you for your attention.
Thank you very much, Santo. So I've been informed that we have Professor Liu back online with us. So Professor Liu, if you can hear us, please proceed with your presentation. Professor Liu, are you with us? If you can hear me, please do proceed with your presentation.
Okay. Good morning, everyone. I'm very glad to join this discussion. I see the time is running out, but I just try to make my presentation short. So I was asked to talk about the deep ocean explorations, but instead I will try to start with deep ocean explorations, but I will conclude by saying that ocean science matters. So a little bit about myself. I'm a physical oceanographer. Study pretty theoretical part of the ocean dynamics and the small scale and meso scale processes in the ocean. So the first question I would ask is why we study deep ocean exploration. So as a species, we are driven by a desire to understand and make sense of the universe around us. We identify and classify every animal we find. We have landed people on the moon and sent probers into deep space to uncover the secrets of the cosmos. We have photographed the surface of other planets like the moon and even Mars, and witnessed our own planet, a blue planet, as a speck in the distant infinity of space. Despite all this, we still have explored just 5% of Earth's oceans. Most of that knowledge lies in shallow waters, while the depths beneath remain a mystery. To this day, we have caught only glimpses of the weird and wonderful life that thrives in the sunless world of botany's trenches and endless deserts punctuated with islands of activity. So every discovery challenges and rebuilds our understanding, from phenomena like deep sea gigantism driving a unique adaptation in deep sea life to alien-like ecosystem full of life forms unlike any others we have encountered. So if you look at a little bit about our ocean, so if we capture the area of ocean depths, you will see that the mean height of our ocean depth around 750 meters, and the mean depth the mean height of the topography on the land is about 750 meters. But if you look at the depth of our ocean, the mean depth is nearly 3,800 meters, and the median is around 4,000 meters. So compared with the mountains we see on the land, actually the ocean is much deeper. So the deep ocean, of course, they are challenging for any for any livings. The deep ocean is dark, it's very cold, in generally below 2 or 3 centigrade degrees, below 3,000 meters, and the pressure is very high. This is the most important things for any living in the deep ocean. So just give you some idea, if you think about the water, so every 10 meters you increase from water, you get 1 atm, which is the pressure we have in now living in the atmosphere. So the deep ocean is really challenging for any kind of lives. So that's why the deep ocean is still mystery, and it's very hard for people to explore, because nowadays, we usually say that it's much easier to go to, well, probably it's not much easier, at least it's easier to go to space than going to the deep of the ocean. Nowadays, with the scuba dive, you can go to around 300 meters, but with the human-made marine vehicles, now we can go to all the way to the deepest of the trenches, which is below 10,000 meters. And of course, once we have the opportunity to go to the deep ocean, we'll see a lot of things, including the new way of lives. And more impressive, actually, for example, in the deep ocean diving in South China Sea, we see a lot of plastic waste found in the deep ocean. This is quite impressive. Of course, it's very sad to see. And if you go to the trenches nowadays, you can see the plastics, and also you can see the new ecosystems inherent to this plastic waste. So this is kind of things we need to care about, not only new science knowledge, but we really look at that, human influence already affects the deep ocean. So just give you a very brief summary. So our ocean are really the defining physical feature of Earth. If you look at the Earth from the space, you immediately recognize it's a blue planet. And importantly, the world ocean is a life supporting system for humanity. Yet it remains largely unknown. And people always say that we know the surface of the Moon and Mars better than we know our own ocean floor, which is true actually even today. So what ocean science? Traditionally, ocean science is defined by the physical, biological, chemical, geological oceanography. However, I think in this new area, I think the ocean science nowadays, we should include all research disciplines related to the study of the ocean. Of course, include physical, biological, chemical, geological, and also hydrographic, health, and social sciences, as well engineering, the humanities, and multidisciplinary research onto the relationship between humans and the ocean. So the ocean science nowadays seeks to understand complex, multi-scale social ecological systems and services, which requires observations and multidisciplinary and collaborative research. So in large, we can see the ocean science can include at least a certain categories like blue growth, human health and well-being, marine ecosystem functions and processes, ocean crust and marine geohazards, ocean and climate, ocean health, ocean technology. So we see that ocean science is not a small subject, it's a larger field. Everything we do on the land, we should do in the ocean. And ocean is not something remote from our common life, it's our home actually. So it's a life supporting system. We should all protect and study the ocean. Luckily, from this year, I launched in January of this year, the United Nations Decade of Ocean Sciences for Sustainable Development. So we call it Ocean Decade from this year to the end of this, to 2030. So the overarching objective of this global effort in the framework of UN is the science we need for the ocean we want. I think they're really an exciting area for all of us to join this global effort ongoing and don't miss the opportunity to be part of it. Thank you very much.
Thank you very much, Professor Liu, and thank you once again to all the speakers as well. I think your presentations have been most interesting, and I think the audience is very much intrigued. We now have some time for Q&A. And I'm not sure whether Elle has any questions for us, but maybe I think while the audience is formulating their questions, let me take the moderator's prerogative to ask a few questions first, and then I'll come back to you, Elle. So maybe Sang-ho, if I can start with you. I think you gave us a very interesting overview of how SAR technology can be used to examine both other worlds as well as our own. And you talked about change detection, the various use cases. Can I perhaps just ask if you can share more about whether there are any new developments in SAR technology that really excite you, and especially those for, I think, new applications on Earth that could potentially be enabled by these new developments in SAR technology?
Thank you for your question, Chris. Yes, SAR technology has been there. It's been around, but getting a lot more public attention these days with emerging private companies launching small SAR satellites. And if you look at all historical applications, the development of new technology, new applications for SAR has been always innovative use of existing technology. And when we see certain signal and we get excited and we have better understanding and remove that, and then we start seeing the smaller signal. Change detection business has been like that too. And for example, we've been working on rapid disaster response to detect catastrophic change on the ground due to major disaster events. And now we're moving on to more subtle changes, such as human activity level change in response to COVID-19. When we do all this, I emphasize the importance of interferometry because a lot of institutes are launching and designing and building SAR sensors and platforms. When SAR images uses just amplitude, without repeat pass capability, it's basically a grayscale image, brightness change you rely on. But once you make it repeat pass capable and make it interferometry capable, you suddenly open up a whole lot more applications. And sensitivity is like 20 times higher than amplitude alone. Therefore, and then also you can suddenly have the same instrument in the space, but now suddenly you become able to measure centimeter or even millimeter scale ground height change. That's a great advantage with no additional instrument, just by controlling the orbit tight and then let the satellite visit the same spot. Then you can do a lot more, as well as like change detection becomes a lot more sensitive. So I'm very excited about this a boom of SAR business, but at the same time, I'd like to emphasize the importance of interferometry.
Right, thanks very much, Sang-ho. I think we look forward to more work on this coming out from EOS. Maybe Elle, if I can turn to you to see whether there are any questions from the audience.
Yes, certainly, Chris. There's an interesting question from Kathleen Cordero online, and I believe that it is around exploration. So there are three main parts to it, and I can repeat the three questions, specific questions to responsible exploration practices. First part, how are we going to address and or prevent accumulation of space garbage? Second, over extraction of outer space resources. Third, are all these covered in outer space treaty? Who and how will sanctions this, how and who will sanction be imposed if necessary? Thank you.
All right, thanks very much, Al. I presume this question is posed to Professor Hanlon, or did
not specifically, but
okay.
Looking at the topic of experts, I think I would say that it could be to Professor Hardy and Professor Michelle and even Professor Liu.
Okay. So would any of the panelists like to take up this question?
I'm happy to get us started just with the really hard questions, and the easy answer is no, the Outer Space Treaty doesn't cover any of that. These are big gaps in the treaty. The only restrictions on behavior, on activities in outer space by humans is that Article 9, this concept of due regard for the activities of others. And so a group of us here at Mississippi are working very hard to prove that having due regard also means that you can't just leave your garbage up on orbit. And so these are gaps that we need to fill within the Outer Space Treaty. And the same goes for this concept of over extraction. The really good news is that the United Nations Committee on the Peaceful Uses of Outer Space has a working group that is looking. It was just instituted last September. And it's going to look specifically at how we are going to extract and use space resources in a sustainable way with limited conflict, or with no conflict, I should say. And the Committee on the Peaceful Uses of Outer Space has also looked very long and hard at the debris issues, debris mitigation, debris remediation. And I know a lot of countries, Japan and the United States, for example, have very strict debris mitigation guidelines for any launches that they send into space. And so the answer is, baby steps. We talk about one small step for humankind. Every step towards that concept of responsible and sustainable space exploration is a baby step, and it's a baby step towards that international collaboration that we want. And finally, sanctions, outer space law is international law. Public international law really doesn't have enforcement provisions beyond sort of wag your finger, name and shame, you shouldn't have done that. But again, the good news is that we are a community of responsible sovereign states. And for the most part, this responsibility and this burden of intergenerational justice and equity, and wanting to make sure that our children also have the same opportunities we have, I think is a very sort of common international theme. Thank you.
Thank you, Professor Hanlon. I wonder if Professor Miyamoto and Professor Funaki, would you like to add anything? And maybe if I can also just add on, because I think we touched on this issue of debris and debris mitigation. I know Japan is trying to play, I think, a large role when it comes to active debris removal. So perhaps if I can ask if you could share a bit more about the work that Japan is doing on this front. Either one of you.
Yeah, maybe for the actual dust removal matter, I think I'm not the person who can really do so. Funaki may talk about it, but let me add a little bit different things in terms of the garbage collection or space debris. The most important reason to make a lot of debris is actually the frequency of the transportation from the Earth to the space. So we cannot reduce it. So we of course need some realistic measure to remove the dust. But in terms of the aspect of space resource, actually the kind of important aspect is to reduce the total amount of the material that should be transported from Earth to space. So if we can get some reasonable fuel or some materials on the moon or asteroid or whatever outside Earth, then it can significantly reduce the transportation between Earth and to the orbit, which ultimately contributes to reduce the space debris in the future.
So I'd like to also comment on this issue, garbage. I was talking about lunar exploration and what happens if garbage appears in the surface of Luna. Bring it back to Japan or the Earth world. Well, we cannot burn it out in the moon. So that means we have to strictly recycle all the material, water, other, everything must be recycled on the moon. Unless that, we have a lot of garbage in lunar surface. So my center also focusing on the development and research of recycling system of lunar surface to perfectly or efficiently use materials on the moon surface and efficiently recycle all the material that was brought into the moon surface. And such kind of activities are also happening or to be happening in the lunar orbit or on the lunar surface. Thank you.
Thank you very much. Right, Elle, are there any other questions? Okay.
No, no more. Thank you.
So maybe you can just stay then on this topic about, I think, space exploration. And, I think Professor Miyamoto, you spoke earlier about the issue of asteroid mining. I think you covered some of the missions that had taken place, those by Japan, like the Hayabusa missions. But I think NASA also now has the, I don't know if I'm pronouncing it correct, OSIRIS-REx mission as well.
OSIRIS, yes.
Yeah, so I'm wondering whether you can share with us a little bit more about how some of these missions have evolved, I think, over the years. And really, what do you see to be next when we're talking about this issue of asteroid mining? I think in your last slide, I believe you covered a little bit about some of the missions that are potentially going to be launched in the future. But if you could give us a sense, perhaps, of where this is really going and perhaps how soon we can see asteroid mining really taking off.
Yes, thanks. For the beauty of these asteroid missions, it's very international, kind of global scale mission. So scientists are from all over the country. The Hayabusa 2 operated by JAXA, OSIRIS-REx operated by NASA, but the science team members are basically from all over the world. Many, I don't know, like at least 100, but much more of the scientists are working together to understand the nature of these asteroids. Hayabusa 2 successfully observed the asteroid Ryugu, and we got a lot of nice observational data, precise imaging, and very good spectra, and obtained the sample, bring it back to Earth, and now it is distributed to scientists all over the world, and they are now measuring, doing a lot of studies of them. The OSIRIS-REx as well, the science team are composed of many people from all over the world and obtained amazing data from the Bennu, the name of the asteroid, target asteroid is called Bennu. Anyways, and the difference, the Ryu and Bennu are totally different bodies, but still they are so-called C-type asteroids, categorized into the very similar category, but an appearance is kind of similar each other, but totally different from other asteroids explored in the past. So scientists are now working on the formational histories, processes of these bodies and why they are looking so similar but different really looking from others, but OSIRIS-REx also obtained the samples, and it's now on the way back to Earth. So these two missions and previous asteroid missions have done very nicely. So I'm pretty sure that the technological level of the human beings now greatly advanced to perform this type of sample return mission from asteroids. And in the future, I showed about 6 or 7 asteroid missions basically operated by the space agencies. They are funded, and they'll be done at least 4 or 5 years from now. Some are already launched, so we will get exciting data pretty soon. But in addition to that, there are a lot of private companies who claim that they can do their own asteroid mission or mining mission in the future. The beauty is, as I said, the delta V from the Earth orbit to the other small asteroids is pretty small. So there are a lot of CubeSats orbiting Earth, and many companies working on that, using the technology of them. And in the future, we have this Artemis mission by NASA, so it can support the commercial lunar exploration as well. So there may be a lot of payload for that, and maybe I have a lot of chance for helping them to send small satellites to asteroids. So in terms of exploration, it is happening very rapidly right now. Your question is actually mining of the asteroid. It's a little bit different. I mean, for getting sample is one thing. It's difficult, but it is possible. People show it can happen. Mining is a little bit different, because so mining them and how to use it, how to process, these are matters that many people are now working on. As Michelle talked about the Luxembourg's leadership in this field, of course NASA's leadership, the people, many companies in the US, they are working on that. So I cannot say when I mean, for the demonstration, it will happen very soon. But I cannot really say when it will be really utilized. It's tough to say, but maybe in 10 years or so. In my understanding, technologically it's ready, and everybody knows that it is useful. So it can happen pretty soon, I guess.
Right. Thank you, Professor Miyamoto. Maybe if I can just pose a question to Professor Liu as well. I think we lost you for a bit, but we got you back. I think, Professor Liu, I mean, when we're talking about deep sea exploration, I suppose, I wanted to ask, you know, what do you think perhaps is the moonshot when we're talking about, you know, this particular issue? What are perhaps scientists currently working towards that would really, you know, open up the next bound for deep sea exploration? Oh, okay, maybe we have just lost Professor Liu. Okay, yeah, I think the connection is not so good. But maybe if I can pose a question, I think, to Dr. Santo as well. You know, you spoke a bit earlier about the work that CRIPS does on the haze. And, you know, I wanted to ask also about, I suppose, the challenges that you currently face when we are talking about both detection, but also in a way whether, you know, more could be done in terms of prevention as well. And, you know, in terms of how remote sensing perhaps can help with things like indicative observables, for example. Can we pick things up before, you know, forest fires even start, and therefore allow the authorities perhaps to intervene even earlier?
Yes. Well, Southeast Asia, or Asia in general, is a very huge place. Without satellite remote sensing, it's very, very difficult to explore and study many of the phenomena that occurs in over the region. In the case of the forest fires and the haze that we sometimes in Singapore suffer every now and then, with a frequency of about a year. One of the main limitations is the cloud cover. Cloud cover is endemic in Singapore and over Southeast Asia. It's about 80% of the time is covered by clouds. So it's very difficult for observability from satellites. And to mitigate that, you probably need much more frequent satellite passes. Also, you need to complement that with ground observations. Ground observations are very critical because you need to validate and you need to actually do a real physical measurement of these aerosols in the atmosphere. And so the second limitation is the very poor distribution of ground sites. We have a very, very tiny number of instruments around the region. Very few in Indonesia or in Malaysia. In Singapore, we have a site in US as well. So all those instruments are complementary because when we observe from space, it gives you a proxy. It's a proxy observation. It's not a direct observation. So we need to complement that with the observations from the ground. So to do that, we need a distribution of instrumentation across the region. That's where Aeronet, for example, this is the NASA sound photometer network, plays a very important role so that we can complement these observations. The haze, for example, in Singapore has been occurring almost every year, but very heavy smoke events occurred in 2006, for example, 2010. Even a sudden event in 2013 in the month of June, which is not supposed to happen. Then 2015, and the latest one in 2019. So we need to be prepared, and in that endeavor, I think remote sensing from satellites plays a very, very critical role. And the new technologies, for example, from Himawari 8, the new Korean satellite, GEMS, which also will be very crucial to understand the transport and the distribution of these pollutants across the region. And that's where the new technologies comes into play.
Right, thank you, Dr. Santo.
Let me add a little bit.
Please.
Yeah, the situation is kind of similar to the Mars or lunar exploration as well. Like a lot of different countries now are observing Mars and the Moon, and for Mars, like orbiters getting a lot of data as a remote sensing, but at the same time, there are several landers as well on the surface of Mars and doing their measurements. Sometimes different countries and provide different instrument, new technology, different data, but all are complementary. So for scientific advance, it's a very I can say it's a with good nature and good spirit. The many countries on Earth are now exploring Earth. So I just wanted to comment on somehow similar situation. Thanks.
Thank you very much. Yeah, I think we have Professor Liu back with us. I'm not sure whether you heard my question earlier, Professor Liu.
So you're talking about the deep sea explorations. We need really the combinations of science and technology. I think. Even in China now, there's very active studies in this field. For example, in the Chinese Academy of Sciences, we had a relatively new research institute called Deep Sea Exploration, and they basically have two groups of people meet together, work together for the science and technology. I think that's the crucial part, and I think for the space science, probably the same, right? First, you need to have the opportunity to go to the space, go to the moon, and to take the photos, and that's the start of the exploration. I think now, although I'm not expert in that field, like my field is physical oceanography, but I can tell as a scientist, a marine scientist here in China, you can see there's a lot of active. For example, they go to the deep trench and get the samples and take videos, and that's really interesting too. And actually, not only for scientific research, they are also interested to the general audience, for our evolution of the deep sea, what's going on in deep sea, right? That's a lot of interest, and yeah.
Right, thank you. Yes, thank you, Professor Liu. Elle, I think we have a question from the audience for the panel as well.
That's right. We have time for one more question, one last question, that is, from Faith Ting. What is the role of emerging space nations in space exploration?
Would any of the panelists like to take this up?
I'll start. Space is for everyone, and one of the most common themes at the United Nations is that every time we think about space exploration, we think about developing nations and the needs of developing nations. And so I think this is actually one of humanity's biggest challenges right now, is understanding how to make sure we bring all of humanity with us when we go on these missions to mine asteroids. And I know that a lot of companies and a lot of space agencies are working very hard to reach out to developing nations and bring them along by sharing some technologies when possible. It's very difficult with a lot of US regulations anyway. But to think really creatively about how we can get developing nations involved. And one thing, we do need to think about, and I think is a very important point, is when we're talking about resources on the moon, that's a finite pot of resources. And so we do need to make sure, like, we preserve orbits for developing nations, and we need to preserve space resources as well. Thank you.
Thank you, Professor Hanlon. Any other panelists?
Let me add a little bit. I think I completely agree with that, and maybe it's idealistic, but working together and share the objectives with many people with different countries are basically very healthy for science exploration. It can happen, and I think a lot of space agencies, NASA, JAXA, ESA. ESA is a very good example. Their missions always open to many other European countries. So just a small contribution, just provide some small reflector or something, it will be appreciated very much. So I think basically, including many nations, are kind of considered very important and healthy to the kind of space exploration by human beings. Thanks.
Right.
Yeah,
Thank you.
JAXA is also waiting for any kinds of collaboration and participation in both science and technology missions. Yeah, thank you.
Right, thank you very much. I think I'm getting the nod from Elle that unfortunately that's all we have time for today. So perhaps on behalf of the organizers, I'd like to thank all the speakers for being with us here and sharing your insights with all of us. I think we found it most interesting. And maybe if I can ask the audience, at least in the studio, to give them a round of applause. Right. Thank you very much. And I think certainly to the audience as well, thank you for joining us today too. And I'll now hand it back to Elle.
Thank you, Chris, and all the amazing insights from our panel of experts. So thank you, participants, for dialing in. And don't forget, we have another exciting session at 4 p.m. Singapore time today, where we look at the future opportunities of geoscience education. And for those who are not dialing back in or coming back to us, don't forget about Honolulu next year. We look forward to seeing you. In the meantime, a goodbye from Singapore. Please take care and be well.